Thank you so much for joining us tonight. I'm Karen Doe with MCA Public Relations. I manage the new media programs at MCA, and we are so excited to be introducing the first in a series of BrightSpots events. So tonight we have the BrightSpots 3D IC panel, which will be moderated by Francoise Von Trapp, Editorial Director of 3D Insights. We have an amazing lineup of panelists tonight, and with that, I'll go ahead and hand it off to you, Francoise.
Thank you, Karen, for that great introduction. Welcome, everybody, to the 3D BrightSpots 3D IC panel. I have with me tonight, to my left, Sitaram Arkalgud. He is the director of the 3D Interconnect program at Sematech. To his left, we have Rick Borges, Senior Product Marketing Manager for Synopsys' Silicon Engineering Group. Next to him, Paul Lindner, Executive Technology Director of EV Group. And finally, at the end, we have Bob Patty, Chief Technology Officer of Tesron Semiconductor Corporation. I want to thank you all for joining us tonight. Just to get things started, we wanted to maybe first define what everyone means when you're thinking about or talking about 3D at the packaging level and 3D at the circuit level. Bob?
Well, we definitely see something very distinct between the package level and the circuit level. Basically, if you're doing 3D interconnect and it's at a larger than 25 micron pitch, that's definitely a package level type application. And then we see below 10 micron pitch vertical interconnect as being more circuit level. And you drive completely different approaches and applications out of those two tiers.
Okay.
Our expertise is primarily in that circuit level 3D integration.
That's actually a good point. Why don't you all identify what your area of expertise is when it comes to 3D? I know, Paul, with EVG, you're an equipment manufacturer. Could you explain a little bit more about what you do?
Yeah, for us, we are dealing with wafers, stacking wafers, and 3D IC for us starts with the TSV, the connection of the wafer front side to the back side, and subsequently either chip-to-wafer or wafer-to-wafer stack. Anything that has to do with wire bonding, we don't consider 3D IC.
At Synopsys, we're a major supplier of EDA design tools. And so our role in this discussion is, of course, from the design perspective, developing the tools for design of 3D ICs. But we also get involved at the technology level with the actual processing, simulation of the processing, and the reliability of the TSVs, for example.
Most of our member companies, in fact all of them today, are IDMs.
Okay.
And we are open to having SATs in the program, but we don't have anybody right now.
Okay.
So really the focus for our program is in the VR mid application,
Okay.
which also falls into the space that Bob was talking about. It's at the circuit level.
Okay.
We have a couple of levels within that. One's the global level,
Okay.
not bond pads, but
Okay.
inside bond pads.
Mm-hmm.
But those require fairly large vias, about 5 micron, give or take a few microns. And then what we call the intermediate level, which goes down to smaller circuit blocks. And that would be about 1 micron or so. And that's really where we are looking at it. We are mid, and then 1 to 5 micron via diameters.
Everyone seems to agree that we're past the initial research level and we're approaching commercialization, correct? So which sorts of, what level of 3D are we talking about there, though? Because when you start getting further into the smaller or the repartitioning level, that's not what we're talking about when you're talking about being in commercialization, correct? Or
No,
yes?
we're very much doing repartitioning. All of our memories are based on disintegrating DRAM into sense amps, I/O, logic, and DRAM cells. And we have a number of sensor customers who have separated out the pixel cell from the analog amplifier, and in some cases also then from the logic that goes behind the image sensor, the camera in a lot of cases. So we have a significant number of people that are doing real 3D circuit level repartitioning.